Okay, geometry class. It is November 2nd. Happy November, everybody. For those of you interested, I'm doing the No Shave November. I normally shave the evening of Halloween. Not that you care. I don't know why I'm telling you this, but here we go. Anyway, I'm already halfway through. I didn't, so I'm going to be even burlier than normal by the end of the month. Anyway. Essential question. I forgot to put a question mark because it is a question. How does a transversal intersecting two parallel lines create congruent and supplementary angles? That's what we're going to be talking about today. Just a note day today. Bell work. How hard did you work last week? Seriously, I've been getting kind of mixed reviews of how hard you've been working. And that is showing through the work that I'm receiving from you guys, because I am still receiving the work from you guys. I'm getting pictures of it, how much you guys are doing when you guys are turning stuff in. You guys, it's still school. I know this is, like, even as 2020 goes, having your teacher try and instruct you via YouTube sucks, and I get that. But we have to make the best of it. So I really need you guys to buckle down and work your butts off. I'll be back Thursday, so we got 3 more days of this. And then hopefully we'll all be back to normal. So I need you guys to do a kind of serious self-check and determine how much work you got done last week and whether or not that was an acceptable amount, whether or not you guys could have done better. Whether or not you guys are using the fact that I'm not there as this kind of pseudo vacation. And if so, knock it off. Because you guys need to be serious about this. So, I know that the different geometry classes, 3rd, 5th, and 6th period may have ended in different places last week, but we're all starting on the same place this week. We're all starting new. And don't go to Miss Sweezy, or I think she's got you guys the rest of the week. If not, don't go to whoever the sub is complaining that, oh, you didn't get to watch the rest of this video. They're online. Like, if you guys are really that interested in it, go online and watch it. Other than that, we'll deal with why different classes are in different places when I get back. And I'm not saying it's necessarily your fault. I'm just saying don't bother Miss Sweezy with it. So here we go. Take a second, take 3 minutes, write down the bell work, and then make sure you have all the note paper, because we're going to be using it today. So we're going to start up. I'm going to put up some definitions and some rules. And so we're going to give you guys some time to copy those down into your notes. And then once you have those down, we'll move on to the next slide and so on and so forth. Once we have all the rules down, we'll get into the more kind of formal, normal note-taking. So definitions: parallel lines, perpendicular lines, transversals, and corresponding angles. So Ms. Sweezy, go ahead, please hit pause. Give them the opportunity to write all this down. If everyone's writing it down and it takes a while, that's fine. If everyone's talking and the 3 people who are actually writing it down get done, just move on to the next slide. Repeat that here. So again, go ahead, hit pause, wait for everyone who's actually doing their work to get this done. Okay, so if I were you, I would put the rules and the definitions in different places. They have different purposes in geometry. So I would put them in different places. A lot of the people put them in the same place, and ultimately that's up to you and how your brain works and how your brain organizes things. But if I were you, I'd have in that 3-tab binder you have, or you were told to get rather, I would have 1 tab for notes, 1 tab for definitions, and 1 tab for rules. So go ahead, hit pause, let them write these two down. Okay, and then again, go ahead, hit pause, let them write these down. And in case you didn't know, the equal sign with a little squiggle on top of it means congruent. So we went over this, we talked about this a little bit in class earlier. Congruent is what we talk about when shapes, angles, segments, things like that are the same. So let's say we have two squares that each have sides of 4 centimeters. We would say the squares are congruent. Their sides are congruent. Their angles are congruent. Now, if we were actually talking about the length of the sides, so we know that the two lengths are 4 centimeters, we would say the lengths are equal. We would say the measure of the angles, 90 degrees, are equal. We would say that the areas are equal. So when we're talking about actual numbers, we say equal. When we're talking about shapes and angles and the physical shape, the square, the side, the angle, not the measurement of it, but the actual physical thing, that's congruent. Okay? Okay, so I want you guys to copy this down. Don't need to necessarily understand it right away. This is actually what we're going to be talking about. But this is kind of your angle cheat sheet. Your parallel transversal angle cheat sheet. If I were you, I would put this on a completely separate sheet of paper. Or get it like tattooed on your wrist. Okay? Because it's really important. It's something that we're going to use a lot. So it's something that it's important to you guys to have kind of easy access to. If you can't read any of them, I'm sorry. Going left to right, I'll read them out loud. Corresponding angles, and then the congruent sign, 1, 5, 2, 6, 3, 7, 4, 8. Alternate interior angles, congruent, 3, 5, 4, 6. Alternate exterior angles, congruent, 1, 7, 2, 8. Same side interior angles, 4, 5, 3, 6. And that's got a 180 next to them because same side interior angles, as you just wrote down, are supplementary. Vertical angles, we went over this last week. Vertical angles are congruent, 1, 3, 2, 4, 5, 7, 6, 8. Linear pairs, 180 degrees. They're supplementary. Remember, those are two angles that form a straight line. 1, 2, 2, 3, 3, 4, 1, 4, 5, 6, 6, 7, 7, 8, 8, 1, or 1, 8. So go ahead, give them an opportunity to write this down. Okay, so what we're going to do now is we're going to talk about actually what that means. So we're going to start off by talking about corresponding angles. Corresponding angles are angles that are in the same position. So here we have our parallel lines right here. And the red line, this one right here, this is our transversal. Okay? It's our transversal. It's cutting across the two parallel lines. Okay? Now, in all fairness, they don't have to be parallel lines for it to be a transversal, but the majority of the time, that's what we're talking about. So we have this transversal cutting across these two parallel lines. Now, the corresponding angles are the ones that are in the same position. And by same position, I mean things like upper left, that's UL, upper right, UR, lower left, LL, lower right, LR, upper left. So notice that when we're looking at this, that same position means up left, up right, down left, down right, right? Correct? So 1 and 5 are in the same position. So when that transversal goes through that bottom line, it creates 4 angles. 5, 6, 7, 8. When that transversal cuts through that top line, it 1, 2, 3, 4 creates 4 angles. So when it does that, and the little blue highlighter marks show that kind of intersection, when it does that, if the two lines are parallel, and this is kind of, it's a postulate. If you go back and look at your notes, it's the corresponding angles postulate, which means we assume it to be true. So parallel lines are coplanar lines, meaning they're in the same plane and they never touch. So if we have a line that hits 2 different parallel lines, and that's going in a straight line, it's going to hit them at exactly the same angle, which means the 4 angles it creates on one parallel line are going to be identical to the 4 angles it creates on the other parallel lines. So that means that 1 and 5 are both created by kind of the same reaction, okay? They're created by the same transversal going through 2 different parallel lines. So 1 and 5, they're in the same position when the transversal goes through 2 parallel lines, which means that they are going to be congruent. They're identical. Okay? And that corresponding angle postulate right there, that statement right here, is the basis for the vast majority of geometry. So it's a postulate, can't be proven. We assume it to be true, and yet it is kind of single-handedly responsible for geometry, for physics, for how buildings are built, for launching satellites and rockets and stuff like that. Legitimately, that statement right there. If a transversal intersects 2 parallel lines, then corresponding angles are congruent. Okay, so what does that mean? How does that help us? Other than just being kind of interesting. So when we move on, the fact that we know how vertical angles work, the fact that we know how linear pairs work, and we've already gone over those last week. So what we're going to do is we're going to take what we know of vertical angles, or we're going to take what we know of linear pairs, and we're going to put that together with that statement that corresponding angles are congruent, and we're going to, show some other angle relationships. So, alternate interior angles are congruent. That's the alternate interior angle theorem. It's called the theorem because we can actually use other definitions, other rules to prove this true. Okay. Angle 3, angle 5. So our 2 sets of alternate interior angles, if we go back to our cheat sheet, it's 3 and 5 and 4 and 6. So I'm going to do the example with 3 and 5, but the example with 4 and 6 would work exactly the same way. So we know angle 1 is congruent to angle 3 because they're vertical angles, right? It's these 2 right there. We know that angle 1 and angle 5 are congruent because they're corresponding angles. We just went over that on the previous slide. So if 1 is congruent to 3 and 3 is congruent to 5, then 3 and 5 have to be congruent. And that's the transitive property of congruence. So remember, the transitive property of equality was that if A equals B and B equals C, then A equals C. What we're doing is something different. We're saying if A is congruent to B and angle B is congruent to C, then angle A and C have to be congruent as well, which makes sense. If 2 things are the same as a third thing, then they have to be the same as each other. So think about it this way. So if I say that Joe is as tall as Paul, and Paul is as tall as Jacob, then Joe and Jacob are the same height. It has to be true, right? And we don't know how tall they are. They could be giants. They could be 13 feet tall apiece. They could be little people at 3'7" apiece. It doesn't matter. And that's the great thing about congruence, is we don't really need the numbers when we're talking about congruence. We're just saying that relatively they're the same. Okay? So if A and B are the same angle, now that can be, they're both 90 degrees, they're both 170 degrees. And B and C are the same angle. Okay? They're congruent. 90 degrees, 170 degrees, doesn't matter. But if A is congruent to B and B is congruent to C, then A is congruent to C. And that's a transitive property of congruence. And that's what we used back here to finish up our logical conclusion of why, if we have two parallel lines cut by a transversal, then the alternate interior angles have to be congruent. There's no other way around it. We know that vertical angles are congruent. We know that corresponding angles are congruent. And if those two things are true, then alternate interior angles have to be congruent. Okay. So notice here, now I'm on each slide, I'm writing a different little chart of the two parallel lines cut by a transversal. You don't necessarily have to do that. If you just want to write down the angle numbers, that's totally okay. So here we have alternate exterior angles. They're congruent, right? That's the alternate exterior angle theorem we just went over. They're congruent. So our sets of alternate interior angles are 1 and 7 and 2 and 8. Now again, I'm going to do the kind of run through on this using 1 and 7, but you could easily do it with 2 and 8. That got all. I must have done that twice for some reason. So if angle 1 is congruent to angle 5, okay? So again, that's corresponding. And angle 5 is congruent to angle 7, right? And the vertical. So again, we're using vertical and we're using corresponding angles. Then we know that angle 1 and angle 5 or 7 have to be the same. And that's transitive property, again. So we linked 1 to 5. We then linked 5 to 7, which let us link 1 to 7. So same side interior angles. Now this is a little bit different because these are supplementary. Okay, which means that when we add up their measures, they're 180 degrees. Or that when we look at them, if we put them together, they form a straight line. So 4, 5, 3, 6, those are our two sets of same side interior angles. See how they're on the same side of the transversal, left or right, and they're on the interior. So I meant to go over this earlier, I apologize. So this right here, this is the interior, okay? It's between the two parallel lines. When we talk about exterior, we're talking about here and here. It's outside the parallel lines. So when we go back and we look at the previous notes, make sure you understand what we mean by interior, exterior. Same side or alternate, we're talking about which side, left or right, of the transversal they're on. Okay, so if they're on the right-hand side of the transversal or the left-hand side of the transversal, if you have one on the left and one on the right, they're alternate. They're on the opposite sides of the transversal. if here, like 4 and 5 or 3 and 6 are on these, like 4 and 5, both on the left-hand side of the transversal. Same side. They're both on the inside of it, so same side interior. Okay, that's how we figure those things out. So if we know that 4 and 8 are congruent, and that's because they're corresponding angles, right? 4 and 8 are corresponding angles. They're both bottom left. And then we know that 5 and 8 are supplementary. Okay, so this is something new. We can then conclude that 4 and 5 are also supplementary. Okay? So I'm going to quick explain how that works once you guys have this down. So if I know that, this is just kind of what I just did, just more spread out. 4 is congruent to 8. We know that because they're corresponding angles. 5 and 8 are supplementary. And we know that because they're a linear pair. If we go back to our cheat sheet, we saw that 5 and 8 are marked off as a linear pair. It's actually the very last one that we marked off. We also know, so if they're a linear pair, that means that when we add their measures together, we get 180 degrees. That's kind of the definition of supplementary angles, right? Two angles whose sums measure to 180 degrees. We also know that the measure of 4 and the measure of 8 have to be the same, because that's the definition of congruent, right? If they're congruent, their measures are equal. If their measures are equal, then they're congruent. If they're supplementary, they add up to 180 degrees. If they add up to 180 degrees, then they're supplementary. So these definitions and these theories and everything, they work both ways. So we know that if we measured 5 and measured 8 and added them up, we'd get 180 degrees, because that's the definition of supplementary. And we know that 4 and 8 have to be the same, because that's the definition of congruence. So we can then do this little neat trick. We can say that 5 plus 4 equals 180 degrees. And that is the substitution property. Because we know that 4 and 8 are the same right there. So that means that this 4, why isn't it writing? That this 4 and this 8 are also the same. So we can switch them out. And that's substitution. Well, if 5 plus 4 equals 180, then we know angle 5 and angle 4 are supplementary, because that's the definition of supplementary angles. Right? Up top, we use the definition of supplementary angles to say if they're supplementary, then they add up to 180 degrees. And then at the bottom, we kind of flip that around and said if they add up to 180 degrees, then they're supplementary. So hopefully you guys got through all of this today. I'm going to be honest, I doubt it. But if not, so we'll pick up on the worksheet tomorrow, or we will finish off these notes tomorrow, or rather for you guys it would be today, and then once you finish this, jump right into that worksheet entitled Parallel Lines, Transversals, and Angles. Have a wonderful Monday, everyone.